Hello and welcome to this video. My name is Vijay Jasankar and I am of this team Vijay Jasankar, Siva Jagdish and Amish Raj, and this is a supplement to our report for the SPE Final Project. Our project is called BLAH for blah blah. In other words, it's a service which stores movie reviews and also fetches movies for you from the IMDb database. So we have a front end and the back end, and as you can see, this is the overall app structure where you have an API and you have a database, which we could pre-populate the IMDb IDs. You load the posters in the ID, and then you can rate the movie from the homepage. I mean, this is the rating page, for example, where you get the poster and you can review and see previous reviews. And you also have JWT token here. So this is a little bit of the high-level overview of this project. Let's look into a little bit more in detail, starting with the backend. So this is the documentation for our project. As you can see, it has been made in MK docs and also deployed to GitHub pages. So let's look at the backend stuff here. So there are three controllers. The block controller, which is the main one, which stores and fetches reviews. So we use MongoDB for this. These are some routes you have, which we will go into more detail. You have register, login, review slash fetch, and review slash new. Sure. Next, you have the delete details controller. Sorry. This basically validates and returns movie details and also makes sure that those IDs which you get are valid. So I'll talk into why that is relevant in a second. And these are the routes you have there: slash details slash valid slash feed, which gets you a random number of movies, and slash recent, the most recent or the highest alphabetical titles in the IMDb ID list. Next, you have the sentiment controller. This is another experimental feature, which essentially tells you it's just sentiment analysis. So it tells you if the movie is positive, negative, or neutral, as defined by our business rules. So let's look at the backend. The entire development was done using GitHub project boards. So as you can see, we have some things that are to do, some things in progress, and other things which are done. Everything was done through PRs, and each PR had their own actions, which were run through GitHub workflows. So, for example, let's look at this action and let's look at this workflow. So this starts Minikube. It also first checks how the repo starts Minikube and sets up kubectl and runs the Ansible playbook. So let's look at those files now. Before that, let's first look at what eventually motivated us to do this project. So we have a lot of movie reviews. However, working with the IMDb API was something very new to us, and we wanted to try it out. Whoever that came up with a lot more problems than solutions. But we wanted to make a place where you can freely submit your movie reviews and find other people who are similar interests and so on. So these are the main models which we used in Mongo. So you can see there's a review schema here, which has the movie ID and the review, and the user schema, which has email ID and the password. Uh, Now, this is the main route. So you have auth register, and the thing to note here is that we hashed each password and we check with hashes only, not in plain text. And we also have login, which returns a JWT token based on a secret key which we've defined. So let's look at these routes now in action. So as you can see, register. Uh, this calls 403 forbidden because the user already exists. And what I want you to notice here is the URL. This isn't localhost. We actually deployed this on Render, which is a service where you can deploy Docker, Node, Ruby, and JavaScript, and so on. As so, we used Docker here. So we can see that it's running now, and we can see the deploy page as well, and we can access this. So this is deployed every time we make a push to the repo. Anyway, so this is 403 forbidden because user already exists. So let's just use these credentials and let's log in, and this will give us a token. This is a JWT token signed and valid for 1 hour, which we were then used to add a review. Now in the front end, the thing is already populated where you click on the page where you can add the review. But let's try something. So the rest you still of this movie from Render just before the demo. So this is just during the demo. uh, so we get 200. Okay, let's look at the reviews now with the same ID as you can see here. Ideally we'd want to see the new review coming at the end and just during the demo, right? So that is the first API. Let's now go on to the second API, which is the details controller. This is the most complex API, I would say, of the remaining two. So what this essentially has are a few responses. The first issue we face was that IMDb doesn't really have a public facing API that gives you all the IDs. So we use the OMDB ID. We use our OMDB API key, but that only gives you details about one movie given the ID. So like this basically. So this is the URL that we would call. However, this doesn't give you all the IDs, and we don't want to cyclically check through every single ID every time. So we found that IMDb has data dumps, which they store as start or gz files. So what we did was we have a script which downloads it, extracts it, and puts all the IDs into a text file, and that is time stamped as well. And after that, it runs this read ids.py file, which basically extracts it into titles. So as you can see, it comes something like this. There's a lot of IDs, as you can see. So if you want to cache all the details by calling OMDB with all of these things, the API response time is just not fast enough for a daily backup. So what we do is when you call this function such as slash feed, what that basically does is checks if there's a file here, and if not, it checks if it starts to make the file, and that file should be less than 24 hours older. So if there's something that's out of date, for example, if I were to make this request tomorrow, this thing would be 24 hours out of date, so it creates a new file. However, we've done a lot of checks in prod, such as we've done flock, which is file locking. So essentially only one script can run this at a time, and we also check the Python paths for different parts or different CI tools, for example. So eventually at the end, what you would get is something like this. And you can see I have run this actually in ngrok. I have port 8000 open, so just for some experimental builds. So this is slash recent. So as per the ID file, this gives us the details of the last 10 IDs. So you can see these are the last 10 IDs, and we also have slash feed. Um, this is the bread and butter of that file which we just created. It extracts from the text file, calls OMDB, and gets the results out. So you can see these are all random IDs, and we can define how many we want, and this is used in the front end as well. We also have a get validity, so this calls OMDB directly. So that way, in the front end, this check is done to ensure that no movie with the wrong ID is entered, even by URL fudging and so on. And you also have a details thing, which is used in rendering the app, as we saw on Figma. Next, we have the sentiment analysis route, and this is fairly simple. Of course, we did try using MindsDB. However, they had a bit of a regression from their last release because of that their Node SDK is not working. I'm sure it'll get fixed very soon, but until then, we use this package known as Sentiment. So this is a very rudimentary way of implementing it, where each word gets a particular score, and you add up the scores based on the positions of that word in the sentence, and then you normalize it. So you get a score of -1 to 1, and this is the business logic. So if it's less than 0, it's negative, 0 to 3 neutral, and above 0.3, it's positive. So based on that, we've also implemented and deployed this rather in on render. So that is the blast senti. So I have added that right here. So let's look at positive. So we can use this in many ways. So right now it's just an experimental feature. We're seeing what parameters work, what doesn't, if MindsDB is going to come back up, and so on. But if you were to use this in our front end, what we can do is, and what we are doing right now is, given a review, we can then color code it based on what we get from here. So the green, yellow, red, and so on. So that is about the services itself. Let's now look at the DevOps part which we've implemented. Obviously, the first thing we have to do is containerize it. So let's look at a sample container for this. This is a Node.js API. So this is the base image. We install all the dependencies, and we run package npm install, and then we expose the port 3000 and start the container. Fairly simple here. Since envs exist here, we put this in git ignore but not in docker ignore, so you can run the image. This is an example env file which we have to fill. So this is the MongoDB URL. Sure. Next, we have another Docker file for our details controller, which is made in UVCon, sorry, in Fast API and run through UVCon. So very simple here again. We run the pip install requirements.txt, which is here. Then we copy all the remaining files, expose port 8000, and run it. Next, we also have one for the sentiment analysis API as well, which is as follows. This is running on port 9000. That's the only difference. Next, after this, we also have Kubernetes deployment. So we have YAML files for each of these. So let's look into that now a little bit more detail. So let's first look at the blah backend, the Node.js one. We have two replicas here, and the app name is Node API, and we run this on port 3000. And we also have a service, which is a load balancer. And this is a combined one. So this is the load balancer for 3000, and this is for the Python one, where we have a port of 8000. And we've also pushed these two Docker images, one for review details, one for movie details. So we pull those images. Similarly, we also have one for the sentiment analysis one. The only difference here is that we use Docker volumes to mount the results. As we wanted to see some diagnostics, we mounted there. I think this gives me a good segue to talk about the logs itself. So logging is obviously pretty important. So let's have a look at some of the logs that we have here. So this is in the ELK format, or rather ECS format by Winston. You can see the timestamp, log level, message, and the ECS version. So this is the kind of logging we do here, and in the details controller, the only difference is that we have like who called what at what time, but we also have a few diagnostic um, messages printed, such as, so the whole idea here is the busy wait cycle of calling the download file, and we monitor that and count how much time it takes for that function to execute. Next, we also have another log file for this, but sorry, we have another log file for this, which is in results, and we can see this is mainly used for seeing some thresholds. So that after that brief segue into the log file, let's look at the Ansible playbook. Um, so this is used for deployment, obviously, onto someone's machine. So we can specify what machine in the inventory file. As of now, it is of my teammates. So we copy the deployment file from here, so which is here, and we start the minikube cluster and we apply it. So this will start the deployment and the service for both of these. And then when this is ready, we can then use this. We can call the service, get the URL, and then run it. So that is the brief intro to the DevOps part we did here. Of course, without mentioning, it does go that we use a lot of GitHub Actions as well. For example, this one, as shown there, sets up Minikube and runs the Ansible playbook. We also have some that are more for the contributors itself. So we have something that greets them on a new issue or a new PR. We label the PRs based on this stuff. So this rule is basically about the size of the Git diff. Then we have stale issues checks, and we also have build and test for both Node.js and Python. So these workflows run depending on what the PR is or what the issues are, and so on. So just to recap, let's look at some of the installation instructions here. So this is for one controller, for example. You can either run the Docker container, or you can deploy it from Kubernetes, kubectl -f, so on. And yeah, so this is a small typo. I'll remove this right now, and we can also run the test. So the tests, as you can see over here, are in this. So we use Pactum to test all the API routes, and for example, this user already exists, so they shouldn't register again, and so on. We also have similar tests for the Python file as well, or the rather fast API file, which is here. We check if, for example, get details, if it gives 200 status code for a valid detail and 404 for something else. And then we can upload these logs, and we can also use these tests in the deployment instance as well. So this is the final render dashboard. This is from a previous project. So we have two here, Blast NT and Blah Mongo, and the third one is on um, NGRock as of now. If we just try to experiment with different things. So this is the front end repo. As you can see, it has a lot of stuff just like the backend repo. We have SRC, and the main file is as follows. And from here we have these browser routes. So we did local routing, so only if you're logged in can you use certain things. We have home, all reviews, add review, and sign up. So let's look at the documentation for that as well. So this is the landing page. This is the sign a user up and home page of the application, and all of the tokens which are stored in cookies itself. So that's how that works. We also have a few new GitHub actions here. Rather, one very elaborate GitHub action which first checks out the repo, installs all the dependencies, and runs the tests, logs into Docker Hub, builds and pushes this Docker file, starts Minikube, and loads up Minikube secrets. So there are three secrets here: username.txt, email.txt, and password.txt. It loads these up and then runs the Ansible playbook. So now let's just look at the Ansible playbook and the Kubernetes file real quick. So this is the Ansible playbook. We can see that it copies the service file and the secrets file, starts a cluster, creates the secret, and deploys the cluster. So this is the Ansible playbook for this. And we also have the inventory, which is again localhost in this case. And here is the Kubernetes file itself, the YAML file rather, the Kubernetes config file. So we can see that this is the container, but this is a private Docker Hub um, repo. So you have to log in as you saw in the GitHub action. We also have image pull. So this is the secrets file. And we also have a service, which is a node port service for 3000. So that is it about this project. All the links will be in the description and in the pinned comment. Thank you for watching.